up to 65% of multiple sclerosis patients exhibit deficit in at least one cognitive domain. Processing speed, memory, complex aspects of attention, executive function are commonly affected. However, most clinical and MRI studies have focused on a dichotomous classification of cognitive functioning, preserved and impaired. Two studies have examined the patterns of cognitive deficits in multiple sclerosis patients, identifying unique cognitive phenotypes using specific impairment criteria. Both these investigations identified 4 cognitive phenotypes, ranging from preserved cognition to impairment in multiple cognitive domains. However, those studies provided 2 sets of operational criteria that allow classification of patients based only on the number of affected domains, without considering the severity of impairment. So the aim of our study was to apply the impairment criteria of the neurocognitive disorders work group for DSM-5 to detect mild and significant impairment in memory, attention, and executive function in a cohort of multiple sclerosis patients. We then identified unique cognitive phenotypes according to the severity of the impairment, mild, significant, and the number of affected domains, 1 or more than 1. We also explore the key demographic, clinical, and structural MRI features of the distinct cognitive phenotypes. So we analyzed the data of a cohort of 243 multiple sclerosis patients, and 5 cognitive phenotypes emerged. 56% of patients had preserved cognition, 15% of patients had mild impairment in one single cognitive domain, 9% of patients had mild impairments in more than one cognitive areas, 12% of patients met the criteria for significant single domain impairment, while 8% of patients had significant impairments in more than one cognitive domain. And the interesting finding of the study is that each cognitive phenotype was associated with distinct clinical, demographic, and structural MRI features, providing an important biological validation for this classification system. I think the results of our work are not consistent with a dichotomous view of cognitive dysfunction in multiple sclerosis. However, I think it's important to note that the criteria we are proposing to the scientific community are the result of critical analysis of other works that took a similar approach. So I believe that the strength of this study lies in integrating several elements that were already present in the literature to provide a new perspective on cognitive dysfunction in multiple sclerosis. I think another interesting finding of the study are the different patterns of cognitive deficits between relapsing remitting and progressive forms of multiple sclerosis. Initially, both forms present mild deficit, but as disease progresses, cognitive impairment in relapsing remitting multiple sclerosis patients tends to worsen, to become more severe, but limited to a single cognitive domain, while it tends to expands in progressive forms. It tends to expand to other cognitive areas in progressive forms of multiple sclerosis. However, I think that it's too early to know exactly how this cognitive phenotyping might aid patient care, because we need longitudinal studies to understand how these cognitive phenotypes develop over time. Once we have more longitudinal data, we will have a clearer insight into how tailor intervention and training programs, cognitive training programs for patients based on their specific cognitive phenotype.